here, how does money grow annually? Okay, so this is something that we've actually looked at before. Future value is 1 plus r to the t. This is if we compound annually. So remember, compounding just means that is when, how often do they actually go and add money to your account. So if we compound annually, that means every year they go and add money. So in the first year, you don't have any money. You just put the money in of $1,000. After 1 year, a 5% account, so this is a 5% annual compounding, will have another $50. Okay, but then the next year, the second year, it's going to have 5% of this amount, and then the next year it's going to have plus 5% of this amount, and then plus 5% of this amount, and so on and so forth, which is why it's 1.05 to the t power. Now, really, that's not really how the money grows, though, because at any given time, if I look at the account right here, I still only have $1,000. I don't have 1,025. I have $1,000. Any time in between when I start and my first anniversary that I don't continue up, this is what it really does. So what I really have, if I go after 3.5 years, I have $11.57 and 63 cents in my account right then. So it doesn't really go up like that. It actually jumps every single time like this. So it's more of, remember when we talked about piecewise defined functions. Oops, I spelled it right the first time. I need to trust myself more. So when I go down here and I talk about different types of compounding, you can see what sort of happens. So if I compound annually, then it just does it one time, once per year. It's pretty simple. Semi-annually, all these are the same. You notice these? The formula is the same. The only difference is in this one will be 2, and this will be 2. Because k equals 2. Because what it does, when it compounds semi-annually, it takes your annual interest rate in half, but it does it twice in a year. So that's how that works. And so we have 2t. And then so if it's quarterly, it's 4 and 4. If it is monthly, it's 12 and 12. And if it's daily, it's 365 and 365. And then compounding continuously is, well, it has an infinite number. And we find out that this actually, as if I make this k as big as possible, we know this tends to e. So we don't need to put any more numbers after daily. Is pretty much daily and continuously is as far as it really goes. So let's do an example. Let's find the future value of $5,000 invested for 9 years at 5% compounded annually. Well, that's going to be 5,000 times 1.05 to the 9th power. So 5,000 times 1.05 to the 9th power. That is 7756.64. So that's how much money you would have there. So let's compare that to monthly. That's going to be 5,000 times 1 plus 0.05 over 12 to the 9 times 12 power. So that's going to be 5,000, let's see what that is, 0.05 divided by 12. 1.004167 to the 9 times 12, which is 108, to the 108th power. So let's see what that is. So 1 plus, I'm just going to go ahead and write this again just so it comes out a little more exact. Okay, then we take that to the 108th power, and then we multiply that by 5,000, and we have a little bit more money. Compounds a little more often, we get a little more money. So that's compounding monthly. What about daily? Let's do it daily. 5,000 times 1 plus 0.05 over 365 times over 9 times 365 to the 9 times 365 power. Let's find out. That's 5,000 times 1 plus 0.05 divided by 365, close that parentheses, to the power of 9 times 365. Enter. 7841.32. So there's all these wonderful things in here. Now, interestingly enough, if I were doing this, I'm just curious, if I were doing this continuously, what would this be? So this would be 5,000 e to the 0.05 times 9. So let's see what that would be. 5,000 e to the 0.05 times 9. $7,841.56. So what's really interesting is you'll notice that the difference between yearly and monthly is bigger than the difference between monthly and daily, even though that's way more times per year. And daily to continuously is literally cents. So you can look at this in a couple of different ways, and really it sort of levels off. And this is the highest you're going to have by investing $5,000 for 9 years at 5%. Okay, so let's talk about that calculator some more. So what's really cool is in your calculator, you actually have a solver that will actually do these things for you. So looking at this problem again, if I go to apps and I go to finance, I have the TMV solver, so I'm going to click on that. So N is the number of compounding periods, K times T. So for an annual, it would just be 1. So let's do the annual. So this last problem was a 5%, so we're going to say 5%. The present value, so that's the amount we invest, 5,000. Payment is going to be 0. We're not going to take payments. Future value is what I want. And we make payments per year, and compounding per year is going to be 1. That's K. And we want highlight end. So we just we want to solve it. And you see this little green thing says solve. So we go alpha, enter. Come on. Am I missing something? Wait a minute. Did I get everything? I think everything's in there. Alpha, solve. Oh, there we go. So that says 5250. How come that is different? Oh, we forgot to put the number of years. Sorry. Number of years. Oh, K times T. N should be 9. Sorry. There we go. Now we can solve it. Alpha, solve. There we go. Oh, you got to go to the future value. Alpha, solve. Why isn't it changing? Why are things being not nice to me? 9. Thank you. Alpha, solve. There we go. 7756.64, which I do believe is what we got on the previous one. 7756.64. So let's do these other ones. Let's change this to monthly. So if I change this to monthly, Then the number of periods I have is 108. Still 5%, still this, but periods per year is now 12. I changed each to 12. Now I go up and I cursor to where it says future value, hit alpha, enter. 78, 34, 23. I can change this to yearly. So n is 9 times 365. Don't you love my computer sometimes? Okay. And now these are 365 and 365. So let's go to future value, alpha, solve that. 78, 41, 32. And yes, it's negative because it's money that they're paying out to you, basically. So that's the way that goes. It doesn't do PE, it doesn't do continuous because that's pretty simple to figure out. So, but it does daily, which is really kind of cool. So this is kind of a neat thing to play with, and you can kind of see, oh, let's see these different compounding types. Okay, so this was the problem that we had and how the money was to grow. So it's the same problem except for our principal is $1,000, and this is, I believe this is the 5%, annually, monthly, and continuously. And I just wanted to kind of show you what it looks like. And you can see that annually just doesn't grow too much. It doesn't keep up with monthly and continuously as much, but look how close monthly and continuously are. You can barely see any pink until you get up here up to 30 years, and then you can see just a little bit. But on this chart, you're making almost the same amount of money either way. It doesn't make that much of a difference. Monthly, daily, continuously. After annually, it really doesn't make a whole lot of difference. So, kind of interesting. And this kind of gives you, this is the chart with those numbers in it to see the difference. So, if you look at year 5, so after 5 years, I mean, annually is, you know, less than $10 from monthly, which is $1 off of being continuous. So still about $1 off. Now we're up to $4 off. And then you can see this annually to monthly right here. Kind of a difference. You know, you're getting into like, you know, $70 here. But here, $6. And over here, your difference is about $5. Here, your difference is about $9. And at the very, very bottom, annually to monthly, okay, that's over $100. That's after 30 years. And then monthly to continuously, $20. So unless you've got something that's going in there for 100 years, it doesn't make that much difference to have something compound monthly versus compound continuously. So let's talk a little bit about present value. So let's say you know how much you want to make. You're saving for your retirement or your children's college or whatever. So how much should be invested compounding monthly at 5% to have $100,000 in 18 years? So let's say you just had a baby and you want to know how much do I need to have $100,000 to get this kid a good start in life in 18 years. Although that might be 1 year of college in 18 years for all we know, for the way it's going, right? So let's talk about that. So let's say monthly, compounded monthly. And how much do I need to invest? So now I need to know what my present value is. So my equation for this, remember, is I need to have 100,000 equal to my principal times 1 plus 0.05 over 12, and then 18 times 12 right here. And I need to solve for P. So essentially, what I need to do is just take my 100,000 divided by this. Or I can use my TMV solver and my calculator, And I can go up here and say, okay, I want n to be 18 times 12, 5%. My present value, I'm just going to clear that. Now I got to put something there, okay. And then my future value, I want to put something in there. So I want that to be $100,000. My compounding is 12. And so I want to know what my present value is. So I go and put my cursor at present value and go solve. And since it's negative, remember that's money that I'm actually putting in and investing. So it says that I need to put in 40,733.06. So that's what I have to invest right now in order to have $100,000 in 18 years. So we can check to make sure that's right. We can do this the other way. If I do 100,000 divided by 1 plus 0.05 divided by 12 to the power of 18 times 12. And I have 40,733.06. So that's the long way to do it. I just take my P is 100,000 divided by 1 plus 0.05, 12 to the 18 times 12 power. And that's all I need to do. So I can check that answer, of course, by taking that amount times 1 plus 0.05 over 12 to the power of 18 times 12 should get $100,000, and I do. So what about compounded continuously? How much would I have to put in to do that? So let's find out. So let's see, 100,000 is PE to the RT, and let's see, we know R is 0.05 and T is 18. So we want 100,000 divided by e to the 0.05 times 18. So oops, you know what? That's my previous answer. Divided by e to the 0.05 times 18. And we have, so you don't need quite as much, but it really doesn't make that much of a difference, right? 97 cents. I suppose. So this is how much that you need to put in. So that's the present value of $100,000 18 years from now if you invested it at 5% interest.